Baby, here it is, a CRT. I call them CRT problems on an IB test. They love them. All right, I think I've seen 3 or 4 on them over the years, right? Okay, so an alpha particle, the mass is 4 U's, and you're like, I don't know what a U is, and that's because we haven't gotten to the chapter. So look on page 2 of your data packet, where all the constants are. Look near the bottom. It's the third one from the bottom. They've got a U is equal to so many kilograms. It's not very much. It's like on the order of 10 to the minus 27th, okay, kilograms. And then the charge is 2e. When they say that the charge is equal to 2 times the electron charge, which is 1.60 times 10 to the minus 19th. So you can look that up. That's on page 2 of the data packet, right? So there it is, right? And of course, this is a problem we've done. I don't know. Hopefully, you've done more than one of these, right? Basically, we're saying that the potential energy, right, is change in voltage times Q, right? And that's going to equal 1/2 mv squared, okay? When I did it, I got the answer that they told me to get, so good luck. Mess with stuff, right? And then B says the alpha particle is traveling, and it's midway between these plates, right? So it's 0.4 centimeters from the top plate or the bottom plate, which means it's 0.004 meters, right? This plate separation is 0.008 meters, right? So the plates are 2.4 centimeters long. They're talking about that. Their separation is 0.8 centimeters. The potential across them is 600 volts. Calculate the magnet or the electric field, the magnitude of the electric field. You're going to use electric field is equal to change in V over R. I think there's a minus sign that we're going to ignore in this case. Okay, so use that one, right? And then it says show that the magnitude of the acceleration of the alpha particle by the electric field is this. You're going to use 2 equations, right? Find the force using E as F over Q. And you just figured out E here. Q is 2 times the electron charge, right? And that'll give you the F. So F is equal to something, right? And then you're going to say F equals ma. And the mass is going to be literally 4 times U, right? Okay. Which you'll have to look up what a U is on page 2, okay? Yeah. So you'll find the force with E equals F over Q. Set that equal to ma, solve for A. I think we did those too. We did them on a test, right? And then the last part here, we've already done this, right? Calculate the time taken for the alpha particle to travel a horizontal distance of 2.4 centimeters, right? Time is just going to be this x over v, right? X over v, right? Where that's the velocity. And the velocity, they tell you, is it's from part A, I believe, right? Yeah. So use the velocity from part A, and that'll give you the time. And it's not very much time, right? It's going a bajillion miles an hour. It's like 50 nanoseconds or something like that, right? And then use your answers to deduce whether the alpha particle passes between the plates or whether it will hit one of the plates, right? So again, this is our fun time, baby. Horizontal, vertical, right? Horizontally, the acceleration is 0 because there's no acceleration anymore, right? This velocity is the answer to part A, right? SUV. I'm assuming that the initial vertical velocity, that it's just moving horizontally, that's 0. This is the answer to this, right? I'm going to plug that in for the acceleration, right? And then the displacement, displacement horizontally is 2.4 centimeters, so it's 0.024, right? And you're going to, you've already calculated the time, right? But you can just solve this thing separately, right? So this divided by this will get you this. Time will go across. And then I guess I would use 1/2 AT squared for this, right? To figure out the displacement, the vertical displacement. And then the question is, will it hit the plates or not, right? There's 3 marks. And one of the marks is to determine whether it will. And I'll give you this clue. from the middle of the plate to the bottom of the plate, right? Because this is what a positive charge thing. So this plate is positive 600 volts, and this is 0. Right? So this is like the negative side. This thing is going to deflect downward, and is that right? That is right. And so if that downward displacement is bigger than 0.004 meters, then it's not going to make it. And if it's less than 0.004, it will make it. Good luck, team.